Okay, so solving systems using graphing. Solution to a system of equations will be the x and y values that make both equations true. Just definition there. On a graph, the solution is represented by the intersection point. So when you graph those two lines, we're looking for where they cross, and we're going to label that with a coordinate. Let's take a look at an example here. Determine the solution to the system of equations graphed at the right. So if I give you the picture, you need to be able to locate that coordinate where the two lines cross. Okay, so I'm looking here. I'm looking at what, over 2 and up 1. Okay, again, remember it's hard for me to see this from my view, so hopefully I'm not standing corrected here from home, but looks to me like over 2 and up 1 is where they intersect. So the solution here would be 2, 1. That's when you're given the graph. Now, what if we need to generate the graph, solve the system of equations graphically? We're going to graph these two equations first. All right, so you can use any strategy you'd like. I'm going to use graphing shortcuts. So my starting value here is -4, and my growth of that first equation is up 3 over 1. So for those of us that struggled during the graphing chapter, okay, you're going to get a lot of practice in this lesson here on how to graph lines. Using all of our variety of methods. It is important that we use a ruler to draw the straightest line possible, since we're looking for an intersection point. And we also want to make sure we extend that line the whole way across the grid, because we never know where that answer is going to lie on the line. Now I'm going to do the second line in red. Starting value of 3, that's the y-intercept. Okay, 1, 2, 3. All right, so don't forget this is a y-intercept. And then the growth triangle here is made up of that fraction, so this will be up 2 over 3. So from this point, I go up 2 over 3. I can already see where my solution is going to be. Okay. I'd still like you to finish the problem, though, and graph the line. So if I graph that line, straight as could be. All right, and now I'm looking for that location of the intersection point. So it appears to me as though that happens at what? 3, 1, 2, 3, 4, 5. So the answer here is 3, 5. Now if I wanted to check my answer, I would plug it into my equations, and they should both work. So if I plug 3 in for x and 5 in for y, I should get 5 equals 5 in the first equation. And if I plug 5 and 3 into the second equation, it checks as well. That's not a required step, just letting you know that you could check your answers in the equations that were given to you. Let's take a look at one more example. Solve the system of equations graphically. Now these equations aren't given to you in slope-intercept form, so just giving this to you to cover another strategy here. So remember that what we did for these, or what you could do for these, for this first one here, I'm going to cover up the x. I'm going to write down what I see. Okay, and I see -5y equaling 10. Which means y equals -2. And then I'm going to cover up the y and write down what I see. And I see 2x equals 10, which means x equals 5. So I plot those 2 points. X is 5, y is -2, and then that's how I draw my line. All right, using those 2 points. These are called the x and y intercepts. All right, so draw that line there. Make sure it goes through both points. Extend it this way as far as it can go. And now for the second one here, I have 2x equals y minus 6. So you have some options here. You could use the intercept strategy again, but it doesn't really work as well because x and y are on the same side. Or you could just add 6 to both sides, and you'll get 2x plus 6 equals y, and we're in slope-intercept form again. So if I go up 6, 1, 2, 3, 4, 5, 6, and then my growth is up 2 over 1, draw my line. Now at this point it looks like it's going to be tough for them to intersect, but again, here comes the importance of drawing a long straight line the whole way across the graph so you can identify that intersection point. And that intersection point appears to be here, and that is 1, 2, 3, 4, -5, 1, 2, 3, -4 would be my answer. That's the solution. If the two lines, these are special cases. If the two lines are parallel, then they will never intersect. Therefore, there are no solutions. Okay, and if the two lines are the same line, that means they're the same equation, and they intersect everywhere. So there are infinite solutions. 2 things you need to know.